Okay, so in this video, we're going to revisit machine learning and the Titanic. We borrowed some code from Hal Varian, his paper on new tricks for econometricians, or big data, new tricks for econometrics. We had set that out. We had implemented that in a Google Colab. So we took that code from Hal Varian, set it up in a Google Colab, little video clip here, and we had worked out using a C tree, this type of tree and leaves type profile, using that machine learning framework. And we had set out also a confusion matrix based on that for the full sample of 1,309 passengers. Now, R works quite well in Google Colab. Sometimes when loading in the packages, you have to write to the console, so that can take a little bit of time and so on. But a nice feature of R is that very often we find in the repositories that there are these data sets that are easy to pull in, and they're a little bit more curated. So we took advantage of that here. And then I followed basically Hal Varian's approach. We had set up a decision tree, and then we had went on, implemented a C tree. It's a little bit distorted in terms of presentation here, but when I set it out in our studio in a more kind of native environment, this was the type of schema we had for a C tree, conditional inference tree. So what I plan to do here is just discuss a little bit the idea. From the C tree, we can set out confusion matrices, and we did that for the full sample of 1,309 passengers. Now in this video, we're going to look again at the confusion matrices, and we're going to pull in some Python code, and instead of just merely running the full sample, we're going to break down the sample into a train and test, use sklearn libraries, and I borrow heavily the template set out here in Medium, so you can follow that link. Maybe we can do that now. Let's see, just have a look. I found this quite useful. Titanic survival prediction using machine learning. And then there was quite a bit of code in here, an explanation in terms of what's going on. So I set that out. All right, I followed that and stick it here in this Google Colab. Okay, so let's just run through a little bit what we've done. I'm going to write out the R file, or the Titanic3 file that I pulled in through one of the packages. It's now here in if we use this code here, we can see where in the directory that went out to. So it's in the content folder, and then we import, because it's Python and it runs natively in the Google Colab here. We can, as a result, set it up, do the data frames and data manipulation. Okay, so we're going to read in that same file then from the Titanic3 CSV, comes into this environment, and then we import in NumPy libraries, which is good for arrays and multidimensional arrays, and then some of the graphic capability embedded in Seaborn and Matplotlib. So we're following the template set out here in the Medium article. We make some changes. So if we read that, just read in the top 10 rows from our data set we got on name, so that extra column there is corrupting a little bit our data set. We need to drop it out. So to drop it, we say take the Titanic data set and just drop the unnamed column that we have here. We run Titanic3 dot head again, and you can see that's gone out. So our data set is back to where we had started with the Titanic3. In the Python environment, here we can investigate a little bit what's contained in our data, and we can observe a little bit some of the values. So we've 709 passengers who were in third class, 323 in first class, 277 second class. And then the numbers who survived were 500. So the ones are the survived, and the zeros are those who perished. So the passengers who perished here, it was 809, and then there's 500 who survived. Then we have the names, the breakdown male, female, and all this we've seen before, but this is a nice way actually just reading through your data, seeing what's in there, looking around to see what are the unique values and so on. Okay, now we're going to drop, because there was quite a few missing ages in our data set, we can drop the missing age and the missing observations from embarked, and so they basically then get removed, and then we can take a look again at this Titanic3 data set. And when we exclude the non-populated cells from these two columns, we've 1,044 rows, and we have still our 14 columns, right? So again, we can have a look here at that, and again, nothing much has changed except we've excluded the cells that weren't populated from those two columns. We again can take a look at our data types to see what's there. So we have objects and integers. So we've a combination of numerical values and then non-numerical. Okay, we can print the unique values. So if you like, when we have here, for instance, sex, it's the object here, female and male, what we observe is that these are our names, right? And we can change those to be new numerical values by using our label encoder, right? So encoding categorical data, transforming object data into integers, okay? So female becomes 0, male becomes 1, Southampton becomes 2, Cherbourg 0, Queenstown 1. Okay, and then we run again, and you can see that the sex now is an integer, and then embarked is now an integer as well. And that previously it had been, both of those had been objects, right? So that's a change that we've made there. Okay, that's fine.